Welcome to chapter 10. So for chapter 10, we are going to do things a little differently. Rather than have like a 10 or a 20, 30-minute video over a section, I'm trying to make smaller videos that are just over one topic. So the topic is going to be phrased in terms of an I can statement. So chapter 10 is I can identify cross sections. So let's go to pbslearning.media and we can identify what is a cross section. So here I have a cube. So if I want to start the activity, I get this cool sword and I can cut it. And I'm cutting off, and this is my cross section. It is going to be the 2D shape that's made, like the image. So this is a non-equilateral triangle. The next one I'm going to cutting. That's going to form an equilateral triangle. So all the sides are the same. Turning it a little differently, cutting. Ooh, so this has 5 sides. Okay, so that's going to be a pentagon. If I turn my cube a little differently, cutting, now it's square. All the sides are the same. I'll cut it like this. Ooh, a hexagon. So I'm getting lots of different shapes by cutting my square in different ways. So here I have a non-rectangular parallelogram. Simple rectangle. And back to the triangle. So, cross section. So I can look at like a bottle. If I cut it down the middle, I'm going to have still a bottle shape, like half. But if I cut it, like a log, I'm going to have 2 circles. So, getting started. First page in your book on page 696. So, a bottle company designs 3 corks. The bottles have 3 different openings. Here are the views of the tops of the bottles. So this would be like a regular bottle. It's circular. That's going to line up with bottle B. For some reason, they make in one that has a square and one that has a triangle as the opening. So the company also designed several bottle cork stoppers on the next page, and we're going to see which ones will fit into each cork without leaving any gaps. So here we have stopper 1 and 2. So if stopper 1 is a circle on top, so it would fit into bottle B. Stopper 2, if I cut it in half, would be a circle, so it would fit into bottle B as well. But could stopper 1 also fit into another bottle? Well, if I take the cross section this way, it's going to be circular. But if I take the cross section this way, it could become a square. So a square cross section would easily fit into bottle A. So stopper 1 goes into A and B. But stopper 2 goes only into B. Moving on. Next we have stopper 3 and 4. So stopper 3 could obviously fit into A. It's square. But could stopper 3 also fit into B? No. Could it fit into C? Answer is yes, because if I take the cross section and I cut off that, I would have a triangle, and that goes back to the initial activity. So it's A and C. Okay, we got stopper 4. That's a square bottom, so it could fit in A. And it's triangular on top, so it could fit into C. You guys do this for 3. So pause the video, check 3 out, and when you're back, we'll go over the answers. Welcome back. So for stopper 5, it's circular on the bottom, so it could fit into B. And then it actually is triangular on the side. So if I cut it down the center with my sword, it would be a triangle. So that could form C. For stopper 6, the bottom is a square, so we could fit into A. And then the side is triangular. So if I turned it on its side where this was the top and that here was the bottom, it could fit into C. So with any stoppers that would only fit into one bottle, so you guys figured out, that's 2, 2, going back. B only fits into one stopper. Because if I cut it this way or this way or this way, it's still always going to be circular. Okay, so now we're going to visualize cutting a tree trunk. So a section of tree trunk is roughly in the shape of a cylinder. When you cut the tree trunk, you see rings. You study the cross section of the tree. So you guys are asked to cut the tree this way, and then at a diagonal. And to help visualize that, I found this fun thing. So here I have a cylinder, we'll call it a tree. And if I cut it where this square is, I'm cutting it this way, and then the shape that is made is circular. If I move it up or down, doesn't matter, still circular. If I rotate this, so it's at an angle, what shape might it make? Well, it looks circular here, but if I turn it this way, it looks circular there, but if I look at this way, it's actually longer this way. This is the diameter across the circle, or the cylinder. This goes longer than that distance, so this makes an oval. And if I rotate this all the way vertical, this is going to make a square. So going back to what you guys have to do. Uh-oh, come on. For these, you'll need to draw these shapes here for 1, A, B, and C. So pause the video and do that. Welcome back. So consider the different cross sections of a sphere. Here I have a sphere, cross section, cross section, cross section. Identify the two-dimensional cross section of the sphere. Well, that's going to be a circle. What do you know about all the two-dimensional cross sections of a sphere? They will all be circles. And we started talking about that earlier with the cork thing. Okay, consider the cube. Describe the 5 different two-dimensional cross sections formed when the plane intersects a cube. So this one would be what shape? Square. What's this one? Rectangle. What's this one going to be? That's going to be a triangle. That's cutting off the corner here. What's this one going to be? A pentagon. And then here we have hexagon. So this goes back to that samurai sword cutting stuff where we could see what we got. Okay, now we're going to cut a pyramid. So why don't you guys pause the video, try this one, and then we'll come back and talk about it. Okay, welcome back. So if I cut it this way, I'm going to have a square. This way, I'm going to have a isosceles trapezoid. This one will be a triangle. And this one is going to be your quadrilateral. So what we're doing with this is you get a shape, you cut it a certain way, and you identify the shape that is made. That's what cross sections are. Okay, so cross section, talk the talk, page 705. Use each solid to create two cross sections. Create one cross section parallel to the base and a second cross section perpendicular to the base. Identify each one of the cross sections. So I'll do A. If I go parallel to the base, that's going to go this way. That's going to be the face here. So that is going to be my hexagon. And then if I want to go perpendicular to the base, I would cut it like this. So that was bad. That would be a rectangle. So you guys pause the video and do B. Welcome back. If I cut up and down, I'm going to have a triangle going through the top, the apex here. I'd have this back side, the bottom, and this side. If I cut this way, perpendicular, horizontal, I'm going to have the same shape on the bottom, just smaller, so it'd be a pentagon.